Hey folks, let's start by looking at an example of a Punnett Square problem. We often use these to make predictions about the percentages or the fractions of offspring that will have certain traits, and that's what we'll do here. For mom and dad who we're looking at the lactase persistence trait. That's the trait that makes it so that you can digest milk or things that have lactose in them into adulthood. So, first off, it says that mom and dad are both heterozygous for lactase persistence. Heterozygous means that they each have one copy of the dominant trait and one copy of the recessive trait. So I'm just going to start by writing out for mom. We have, let's see, for lactase persistence on my sheet it says we're using L's. So I'll do a capital L, and my lowercase L's I always worry they look like ones. So I'm just going to do a script L, or a cursive L for that. And then for dad, we'll have the same thing. Capital L and a lowercase l. Next up, we're going to figure out what their gametes would look like. So for mom, we're talking about egg cells. For dad, this would be sperm cells. Gametes have just one or the other version of this gene. So the gametes for mom would be either L or big L or little l, capital L or lowercase l. So it's just one or the other. And dad has the same setup, so big L or little l. And then for our Punnett square on this, we're just going to set up a square where we have dad's gametes up on top, and that would be big L or little l. And mom's are going to go down the side, big L and little l. I'll label those. Okay. And then to fill in the table, all we need to do here is look at, for this square, what's up above here, and what's to the left. So for this square we have a big L up top and a big L to the side. And so we'll have big L, big L. For this one we've got a little l up top, a big L to the side. The convention is just always write the capital letter first, so it doesn't matter which side we have the capital and which side we have the lowercase on. So we'll just do big L, little l, just like mom and dad. Here we'll have the same sort of thing. We have a big L up top, a little l on the side, so big L, little l again. And then here, little l up top, little l on the side. Little l, little l. So, on the top and on the sides, those represent the gametes from mom and dad. So what do these middle things look like? What do they represent? Well, those are the possible combinations of gametes. And when gametes combine, that's where we're making a new creature, a new offspring. So this is like the embryo for mom and dad, or what will become the baby. And there are 4 possibilities, each equally likely. So there's a 25% chance that this will happen, a 25% chance this will happen, 25% here, and 25% there. Notice that we have the big L, little l showing up twice. So there's a 50% chance we'll end up with a big L and a little l. 25% chance it will end up with big L, 25% chance it will end up with a little l, little l. And those different combinations of L's we just call the genomes for the genotypes rather, for the offspring. So our offspring possibilities, 25% of them are going to be big L, 1 out of 4. 50% are going to be big L, little l, and 25% are going to be little l, little l. Now the question asked, what's the likelihood that their kids will be lactase persistent? Lactase persistence is a dominant trait. So as long as we have at least one big L, then the kid will have that trait. So these all together, those all have one big L. So that is 75% of their offspring would have that lactase persistence trait. Only 25% would have lactase, non-lactase persistence or lactose intolerance. So the answer on this is that 75% will be lactase persistent. So now that you've seen the example, worked through that a little bit, and you get a chance to practice with some of the Mendelian traits, the simpler ones with just one gene involved. So you'll get a worksheet that will look like this, and you'll spend a few minutes working through the problems that they give you. I just gave you the full Punnett Square for each one of these. You may not use every column if you only have one type of gamete being produced, but you've got it available anyway. And then the last couple you'll see have, the last three I guess, have questions about how likely it is that any individual offspring will get the particular trait. So complete those, and then there will be an answer key taped to the counter on the side of the room, the right side if you're facing the front of the room. So check that afterward and make sure that you have done things correctly. You'll have about 10 minutes to work on this and get everything checked. And then we'll be moving on to the next part, which is called polygenic inheritance and is a little bit more complicated than this. Also, just a side note for this worksheet, you'll have these papers printed out on your table. You'll need to reference these to know which are the dominant and which are the recessive versions of the trait. And then there's letter conventions established here that I'll be using in the answer key as well. So make sure you're using those.